All right, here we go. So this is 6.14 graphs that represent situations. So this is going back to the context of what equations mean. And luckily, we already discussed this when we had quadratics earlier. For example, what am I doing? Why am I using y? There we go. I should be using f of x. So, for example, uh, f of x equals, let's say, negative 16 x squared, and let's say plus 45 or 40. Let me think of a number. 48, sure, why not? And plus, I don't know, how about we do 80? Okay, so this is a great example. So if we remember, the coefficient in front of the x squared is the part that gravity has to play, involving a jumping frog, a cannonball, a flying pumpkin, anything that involves flight, even orbit of a planet or a rocket, or even just an apple being thrown. Anything that's any projectile that's flying goes through a quadratic function. So you have gravity. Okay, gravity. And negative means it's, what goes up must come down. It'd be very scary if gravity was not negative. Now, this part right here is your velocity, basically how fast said object is going. And this is the initial height that the object launches from. All right, so if it launched off a mountain or a hill, that number would probably be pretty good. If it was launching from sea level, that number would be zero, right? If it was launching below sea level, be a negative number, which happens. There's some cities that are actually below sea level. It's rare, I think. I need to look that up. All right, so 14.1, a jumping frog. So we have the height of a jumping frog, and it's modeled by a quadratic function because of the t squared part, where time is t after it's measured in seconds. So don't forget that's our context. So negative 75 and 60 right here, and inches. This is another contextual thing that we don't want to lose. So don't forget context. So it's inches per second. So some of you are like looking at the velocity from earlier, and you're like, that frog flew 60 feet per second. No, no, it's inches. It's inches. That'd be one dangerous frog if it could travel that fast, right? All right. So, wow, I don't know what I did there. There we go. Clicky clicky. All right, so find h of 0 and find h of zero point 0.8. What do these values mean in terms of the frog's jump? So what I want you to do, and this is purely you, like you are doing this. I am not going to. I'm not even going to look at it. I'm not even going to do it for you, but I will do this. I will set it up for you, or at least the first part, okay? So set up for 0 seconds. So you're going to have 60 times 0 minus the 75, and then plug in the 0, which is being squared. And what do you get for the height? And I'm going to be honest, 0, right? 60 times 0 is 0. Negative 75 times 0 is 0. 0. So it looks like I already did one of them for you. So in 0 seconds, the frog is still on the ground. It didn't go anywhere. That's a good one. But what I want you to do now, and you can go ahead and use your calculator for sure, especially because decimals are kind of weird to work with sometimes. Go ahead and try 60 times the zero point 0.8 or zero point 0.8, doesn't matter in the calculator, minus 75 times the zero point 0.8, which first must be squared. And then what do you get? Okay, so that part is for you. And tell me what it means. So this one means uh, in 0 seconds, the frog is 0 feet. Um, in height. So in the altitude in which it's flying, not flying, falling with style, as Buzz Lightyear would say. All right, so go ahead and do this one, okay, and find the height of the frog in zero point 0.8 seconds. Now, how much time, so they're focused on the seconds here, after it jumped, did the frog reach the maximum height? So if you remember, the maximum or the minimum height of a parabola is also at the point of its vertex. So what you want to do is you want to go ahead and remember what we talked about. So we have 0 seconds, right, from when the frog jumped, and zero point 0.8 seconds from when the frog landed. If you guys remember about me talking about your x-intercepts, and that was as good as I could draw it, what do we know about the middle? Is that going to be your max? So that's going to be your answer right there. So give me your answer. How many seconds? And this is your hint. Okay. So go ahead and find that number, and I'm not going to go over it, but it's kind of a shout out to lesson 11, I believe. So go ahead and think about the notes from that. All right. Next up, a catapulted pumpkin. Why not? Why not? So we have this equation, right? We have, where's my touchpad? There we go. Okay. Lost track of my pen. So we have this function. All right. And it represents the height of a pumpkin that's catapulted up into the air in seconds. So, sorry, my kid is trying to go to sleep. My wife's on it. All right. So, the height is measured in meters. So, don't forget about context. We're talking about meters per second above the ground. So, the pumpkin is shot up at a vertical velocity of 23.7 meters per second. So, that's how fast this thing is traveling. And so I think, yeah, all right. So number one, without writing anything down, consider these two questions or these questions. What do you think the two in the equation tells us about the situation? And that's kind of a think about what I wrote originally in the beginning of this. All right. And what about the negative 4.9? So that's basically what does this mean and what does this mean in context to the pumpkin? I believe they call it pumpkin chunkin, I think, right? Pumpkin chunky chucking? Pumpkin chucking? Yeah, they launched, right, pumpkins. I think they also have cannonballs or something like that. It's a little thing they do. I don't know where. All right. If we graph the equation, um, will the graph open upward? Okay, which will look like this, or would it open downward, which will look like this? And you can totally use Desmos and type in the equation to verify. Where do you think the vertical intercepts be? So when is it going to cross the x-axis? All right, and you can totally, again, use Desmos. What about the horizontal intercepts? So is it going to cross the y value at all? Is it going to cross the y value at all? Totally use Desmos to see that, okay? All right, so graph the equations using graphing technology, and that's the Desmos. All right, I highly recommend that. And identify the vertical, horizontal intercepts, which you can totally see again. The vertical, let me use my highlighter here. We'll use bright green for vertical. Your vertical intercepts is right here, right here. Basically, it's either up or down. And your horizontal, let me use the bright pink. Yeah. Your horizontal is on your horizon, which is on your x-intercepts. Okay. And then don't forget the vertex is either the highest or the lowest point on the graph. Okay. So just be aware of that. Okay. So go ahead and try this on your own. Use Desmos. I'm not going to give it to you. But if you have any questions, feel free to contact me through the normal scripts. All right. Have a beautiful day. Bye.